Similar figure. Similar figures are shapes that look alike, but will be different sizes. Similar figures are figures whose corresponding sides are proportional. Well, let's see. If I have a height on this triangle on the left, it corresponds to the height of the triangle on the right. The same with the base to the base and the hypotenuse to the hypotenuse. Those are corresponding sides, and they should be within a proportion. That means if triangle got multiplied by scale factor of 2, the other one, every side would have gotten multiplied by scale factor of 2. Let's look at what we really mean by all of this. Which triangle is similar to triangle A? To find out, we will use a proportion. I will look at triangle A and see, I'm going to compare it to triangle B and see if these two are actually similar. When I set up a proportion, I pick a pattern and I stick to the pattern. I like the pattern left to right. What I'm going to do is I'm going to, let's say, set up left height to right height, and that should equal to the ratio of left base to the right base. Now let's substitute in the numbers. I set up a proportion, pick a pattern, and I'm going to stick to the pattern. Left height is 30, right height is 45. Left base is 16 and right base is 26. When we have a proportion, these numbers have to cross multiply and both sides have to equal to each other. If they do, these two triangles will be similar. So let's see. We're going to do 30 times 26, and we want to know, does that equal to 45 times 16? 30 times 26 is 780, and 45 times 16 is 720. Uh-oh, those two figures are not similar because those two sides, right, of the equal sign are not equal. Now let's see if triangle C is similar to triangle A. Let's set up a proportion. I'm going to go height to height, right? That is my ratio. I'm going to corresponding sides is my heights, right? So left height is 30, right height is 15. Then I will go base to base. Left base is 16 and right base is 8. Let's cross multiply and let's see if both sides of the equal sign will equal to each other. So we will do 30 times 8, and we want to know, does that equal to 15 times 16? In your calculator, you will plug in 30 times 8 and you will get 240. And indeed, that does equal to 15 times 16, which is also 240. So triangle A is similar to triangle C. Now let's see where we can also use proportions. If you look at this example, proportions will help us to find unknown side measures as long as we have two similar shapes and we are given 3 side measures and we're looking for the fourth one. So we're given 3 and we're looking for fourth. We have similar figures. We're going to set up a proportion. I know that this height corresponds to that height, this base corresponds to that base, and let's go. Left height is 6, right height is unknown. Left base is 10, right base is 25. Let's cross multiply these and let's see what we can do with that. So we multiply 6 times 25 and we want to make it equal to 10 times the x. 6 times 25 is 150 and that equals 10 times x. Well, we're looking for the x, right? To undo multiplication that is kind of attaching the 10 to the x, we have to divide. and we'll be dividing both sides by 10, and that will give us 15 equals x. Now, what do we want to make sure that we will do before we say yes, it's 15? We are going to do a check. Check is going to say yes, you're right, or no, you're not right. So let's set up a proportion. We have 6 to the x, and now we know x, that's what we're saying, is 15, and that should equal to 10 to 25. Let's cross multiply. 6 times 25 should equal to 15 times 10. And 6 times 25 is 150, which does equal to 150. So our answer checks and we are correct. Let's see if we have one more problem in here to solve. And we sure do. It's a word problem. We have a 10 feet long light pole. And that light pole is casting a 15-foot long shadow. A person is standing nearby and that person is casting 9-foot shadow. We want to know how tall is the person. To solve this, I am going to kind of sketch out what I actually have. Well, I know I have a light bulb, right? That is 10 feet. And the shadow of it is 15. A person that is kind of next to it, right, nearby, is unknown height, so I'll put x. And the person's shadow is 9 feet. Now I can set up a proportion. I have 2 similar figures. I'm given 3 measures and I'm looking for 4th one. I go height to height, base to base, left to right, so 10 to x should equal to 15 to 9. What do we do now? Cross multiply and let's solve this. So we have 10 times 9, right, should equal to 15 times x. And 10 times 9 is 90, which equals to 15 times x. Now remember, we're solving for the x. So we have to get rid of the 15 by dividing. What we do on one side, we do on the other side. And 90 divided by 15 is 6, and 6 is equal to x. So we're saying that that person is 6 feet tall. Now just to make sure we are correct, we're going to do a little check. So let's do our check. We're going to set up that proportion. We're going to substitute in for x and see if both sides of the equal sign are actually equal to each other. So we go height to height, left to right. So 10 to x, and we say x is 6, should equal to base, 15 to 9. Let's cross multiply. 10 times 9 should equal to 15 times 6. 10 times 9 is 90, and 15 times 6 is also 90. So our answer checks and we are correct. Please remember, guys, proportions will help you solve so many things. As long as you have similar shapes, similar figures, you missing one unknown, you can always find the measurement.